Hey, welcome to another video that we have on proving triangles to be similar. We discussed in the last video that one way to prove triangles similar was the angle-angle similarity theorem. You're going to get two more today, and then we're going to discuss a little bit of indirect measurement. And I know you're sitting on the edge of your seat, so you better fasten your seatbelt. We're about ready to start this ride here. It's like bam, right off the bat, side similarity theorem. There you go. It's the lengths of the corresponding sides, and when I say corresponding, we know that I'm talking about like the bottom of the triangles, and then maybe like the left sides of the triangles, and then the right sides of the triangles. So if the lengths of the corresponding sides of the two triangles are proportional, then the triangles are similar. And let's look at this example we have up here. Look at the left side. We have 2 over 4. The left side of the triangle, we have 2 over 4. Or, remember, it could be 4 over 2. However you want to say it. Is 2 over 4. Now let's look at the right side. We have 3 over 6. And we also have 6 over 3 if we thought about it like this. And then on the bottom, we're going to have 4 over 8. And then we will also have 8 over 4, depending on how we looked at it. So all you had to do was one of those, either this one up here or this one down here, and then just to make sure they're all equal. Now, granted, we knew that all these were centimeters, so you always have to make sure you pay attention to the units. And how come I didn't put centimeters after every single one of these? Science teachers like me to tell you this. If you have 4 centimeters on top and 8 centimeters on bottom, we can cancel centimeters off with centimeters. So therefore, all we have left is 4 over 8, which gives us the ratio of the sides. Now, I didn't need to write centimeters for everything because I know they're all going to cancel off. So let's go ahead and do some reduction here. 2 over 4, 1/2. 3 over 6, 1/2. And 4 over 8, 1/2. And so we know that all those sides are proportional, so therefore the two triangles are similar. And if we wanted to write a similarity statement, triangle ABC is similar to triangle DEF. It didn't ask for a similarity statement, but I just went ahead and did that for you. Okie dokie. Looking here, determine if triangle MKL is similar to triangle PRQ. MKL is similar to triangle PRQ. Well, maybe it might be helpful if we take this triangle and we write it, or we draw it, to be similar looking to this one up here. So if we're going to rotate that one, the long base is going to be R and Q. And then so this one right here is going to be P. So now what is that vertex going to be? Well, maybe R. You see how it's R? So let's go ahead and put R and Q here, and then we're going to fill in some numbers. So from P to R, that would be 12, 24 down here, and 18 here. So now let's determine if they're proportional by creating a statement of proportionality. You can actually use numbers here. You go ahead and try that on your own and match it up with mine to make sure it is the same. If you need to pause the video, do so. Okay, I'm looking KM RP. It's 10 over 12, which divide the top by 2, I'm getting 5. Divide the bottom by 2, I'm getting 6. Let's look at ML and PQ. ML is 15, PQ is 18. Divide each one by 3. 15 divided by 3 will give you 5. 18 divided by 3 will give you 6. And now let's look at the bottom. KL and RQ. KL is 20. RQ is 24. So I know 4 goes into both of those. 20 divided by 4 is 5, and 24 divided by 4 is 6. So if we look, they all have the same, all sides are proportional. They all have the same ratio when you reduce them. So therefore, this is true. That is true. Wow. Here we go again. We got some good stuff going on the screen right now. Side angle side similarity theorem. This is going to be the last similarity theorem that we discuss. So far we have angle angle similarity theorem, side 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 similarity theorem, and side angle side similarity theorem. It says if an angle of one triangle is congruent to an angle of a second triangle. Well, if we look here, we have congruent angles. Okay, and it's real important, the lengths of the sides, including, here's the big key word, including the angles are proportional. Then the triangles are similar, including. So if I'm looking here at this angle V, what two sides make up angle V? That would be VU and VW. So those are the two sides that include angle V. Looking over at the left triangle, side KL and side LM include angle L. So now let's look at their corresponding sides. Let's see if they are proportional. Well, from the left to the right, I'm going to have 12 over 9, and I'm going to have 20 over 15. Let's go ahead and reduce these. 12 over 9, 3 goes into both of them. 12 divided by 3 is 4. 9 divided by 3 is 3. So that one's 4/3. 20 over 15. 20 divided by 4 is 5, but 20 and 15, 4 does not go into 15, so I cannot use 4. I got to use probably 5. 20 divided by 5 is going to be 4, and 15 divided by 5, that is 3. So there we go. The sides including the congruent angles, the sides including those congruent angles are proportional, so therefore you have side angle side, proving these two triangles to be similar. Any questions? Questions? Any questions from those in the back? No? Okay, good then. Let's look at this one. I would like you to determine if triangle ABC is similar to triangle A prime, B, C prime. And this little symbol here, I'm calling it prime. Calling it prime. A prime, B, C prime. And that's just another way to just say that those 2 points are not the same. If we look here, point A is different than point A prime. So if you're looking here, if I were you, I would probably separate the two triangles. If you're having a hard time seeing what's going on here, I would probably separate the two triangles. That way you can see what's going on. So I'm going to draw the large triangle here. So this is B, this is C, and this is A. Now, if I'm going from A to B, what is the length from A to B? Well, I have a 6 and I have a 4, so that's going to make 10. What is the length from B to C? Well, I have a 3 and I have a 2, so that's going to be a 5. Now what I would like you to do is look at this small triangle. And let's plug in some numbers. So this is what we really have. So now looking here, Is there any other piece of information, looking at the two triangles that we have separated, is there any other piece of information that you know to be congruent? Well, you see AC down here, and you also see A prime, C prime here. Don't get those confused. Remember, those are different segments. Remember, they're not the same. I know some of you are thinking reflexive property, but they're not the same in this picture, the original picture. Is there anything else? The reflexive property is the reason why angle B is congruent to angle B. If you notice in the original picture, isn't angle B the same in both triangles, the small one and the large one? So this is a concept that you got to start recognizing, is that sometimes they share the same part. So now determine whether they are similar. 4/10. They're both even numbers, so divide each one by 2. 2/5. And that one right there doesn't need reduced. 2/5. So therefore, since the sides are proportional, and those sides include the congruent angles, triangle ABC is similar to triangle A prime, B, and C prime because of the side angle side similarity theorem. We're going to save this one for the next part. I'm going to take a pause here and come back with this one in a moment.